You mentioned something before that there are a lot of tests out there you could do for brain. Most of them don't really make the cut, according to you.
Right.
We see a lot of this because there's apps for it, and a lot of them are based in language, cognitive function, things like that. Where
Sure.
yours is quite different in that it's basically sensory first and foremost. What is
Correct.
that great advantage over that from others that claim to improve your cognitive function by doing the app based and more language based things?
Yeah. Okay. There's several different ways I can go on this answer, but that's a great question. Language-based tests, basically, they're not just it's not just that they're language-based; they're also inaccurate. To be quite frank, we published a paper a couple of years ago that made us very unpopular because what we did was we found that just they're not accurate for things like reaction time. Reaction time is a great measure to talk about because everybody understands what reaction time is. They say, oh, that's how fast you respond and how fast you react. And so what we do is we deliver a stimulus to the finger and you respond with another finger. It's that simple. And basically, this test has been done for over 150 years. It's been published. These results have been published over 150 years. And from 1850 until 1970, the results were the same because people were using high-grade laboratory equipment, even back in the 1850s, very, very precise equipment to measure what your reaction time was. Around 1970, with the advent of personal computers, everybody started collecting reaction time with personal computers, which have layers of problems. For example, every time you probably never experienced, I'm sure all your viewers have experienced like a software update on their operating system on whatever computer they're using. Every time you get an update, it's slowing your computer down. And what we did was we did a little test comparing the brain gauge for reaction time, and we compared it with other systems. And the way we did that, we didn't use humans. We didn't use thousands of humans to do this. We built some robotics to do the testing. And the brain gauge is actually extremely accurate, down to a third of a millisecond. And some of these other measures are between 40 and 500 milliseconds off. Your reaction time is typically 200 milliseconds. So if you add 300 or 400 milliseconds to that, that's not good. You can't just subtract that offset because that offset is different every time. And so it might, even if you were exactly right every time you took that test, and you say you tested at 200 and you added 200 and you were 400 one day, the next test might be 600 or the next test might be 500, even though you were exactly the same. So it's very inaccurate. And so that's one big advantage is that we actually have developed laboratory equipment grade hardware that we put inside the brain gauge, and it bypasses the computer and just sends the answer to the computer. That's one of the big advantages. One of the problems with language has to do that I run into a lot. I didn't really think about this much, but a lot of clinicians work with a lot of different socio-demographic groups. And they say, yeah, the language barrier is huge, especially if you have people that, English is not their first language. That adds a whole nother layer of complicity on it. But also different groups, different demographics interpret things differently and answer and respond differently. What the brain gauge does, the different tests that we do, target specific mechanisms of information processing. And so that's what's very different. And so a lot of these language-based tests, what they do is they'll do things like, come up with ways or protocols to come up and look at learning and memory, for example. We do things like where we target the basic fundamental mechanisms that contribute to learning and memory. So like one of them is lateral inhibition. Lateral inhibition is a very, very important mechanism. And the way to think about this is to think about if we deliver stimuli to two fingers, those two places in the brain that are getting active are side by side and they're fighting. So in the brain, what you have all the time is a fight or a fight to maintain balance between excitation and inhibition. Everything in your brain is either excited or inhibited. It's either being turned on or it's being turned off. And that fight that's going on is really, really important and really important to maintain. It's your healthy connectivity that maintains that balance. But the way to measure lateral inhibition is to activate a couple of places in the brain and activate one that's larger than another. And you activate when you deliver one stimulus that's larger than another, the larger activity will try to suppress the smaller activity. And so if you got two places that are side by side fighting and your lateral inhibition is healthy, then you can tell the difference between 2 points in the brain. If it's not healthy, then you have a lot of trouble with that. But anyway, that's a basic mechanistic thing, and that plays a huge role in learning and memory, as does some of our other measures like plasticity and information processing speed. So all those things play a big role in learning and memory. And so, but we are testing the fundamental building blocks versus these language-based tests, which are really kind of looking at high-level things, which can, you can kind of rewire and run around and trick things. It's a lot easier to cheat on the language-based test.
Yeah, I mean, it's definitely an interesting aspect because so much of what we think is brain function is based in that cognitive type of memory things and not so much in the reaction. Listen, we sit around all day, right, and we don't use our reactionary time that much at all anymore. We're not escaping some saber-toothed tiger, having to be on edge or anything like that. We're on edge now because of technology and information, getting ourselves stressed that way.